Hi team, Mr. Rato here. How you doing? Hope you're well. Okay, today we're going to be looking at using graphs and finding intersections of graphs. Okay, so let's have a look at this. And it says here, solve simultaneously these two. Okay, what you can see straight away here that this, and this do the same with different signs. So what I'm going to do is just call one of them equation 1. Call this one equation 1. Call this one equation 2. And what I'm going to do is solve them simultaneously. I'm going to do equation 1, add equation 2 is going to give me, so I've got 3x plus 2 to the power x equals 13, and I've got 3x minus 2x equals 5. Right, so if I add these equations together, if I add those, I'm going to get two lots of those. I'm going to get 2 times 3 to the power x. These obviously got to cancel each other, right? You got a positive 2 to the power x and minus 2 to the power x. So when I add those together, they will disappear. That's the whole reason why I've done this. And I've got 13 plus 5 is 18. Now I've got two lots of those, so I'm timesing this by 2. If I want to take this times in bit, this dot means times. If I take it to the other side, times becomes divided by 2, so I end up with 3 to the power x. 3 to the power x equals 9. And 9 I can put in terms of 3 squared. 9 is the same as 3 squared, so 3 to the power x equals 3 to the power 2. And as the base is the same, the powers must be the same. Therefore, we can say x is equal to 2. Okay, so now if x is equal to 2, oh, yeah, that's it really. We've done it. Finished. X is equal to 2. I thought there might be a y there. There's no y there. So that's it. You can put the 2's in there, double check if the solutions work, but simple as that. Okay, try another one. Okay, now in this situation we have got x and y, so we're solving for the 2. So what's the first thing I'm going to do is I'm going to sub this, what y is, into this equation. So I'm going to replace this y for y equals 2 to the power x. So let's do that. So sub into this equation, so I'll end up with 4 to the power x plus 2 to the x equals 72. Now straight away here I can see what I'll say is a hidden quadratic, because I know that 4 and 2, how they're connected. I know 4 is the same as 2 squared. Okay, so I'm going to replace this 4 the 4 by 2 squared. So that's going to be 2 squared to the power x plus 2 to the power x plus 70 equals 72. Now I'm going to switch those around because there's going to be times in, so it doesn't matter whether I write 2 times x or x times 2. I'll explain to you why I'm going to do that in a second. So that's going to be 2 to the power x, and I'm going to put the 2 there because 2 times x and x times 2 are the same thing. And I've got 2 to the power x, and that's going to give me 72. Now the reason why I've done this is because now I can say let m equal 2 to the power x, and by letting that equal 2 to the power x, you can straight away see I'm going to get my quadratic, my hidden or disguised quadratic. So that's going to be replaced by m, so that's going to be m squared plus m equals 72. Now all I need to do is bring that to one side, so I'll get m squared plus m minus 72 equals 0. Now straight away 72, what makes 72 is 8 and 9 with a difference of 1. 8 times 9 is 72, so straight away we can factorize this, put m in each corner and put the 8 there and the 9 there. Now that's going to be a positive and this is going to be negative. I'm sorry if I'm doing this pretty fast. There are a few videos. I have chosen the tough questions on some of these exercises. and you should be already taught some of the simpler stuff and some of this connecting up, and that's the only reason. I've done this really for people struggling on the tougher questions. However, if you are struggling on some of the easier questions, if you send me a message on YouTube, I can have a look at those questions and try to do them, or post me some questions and I will do them, make videos of them and send them back to you. Okay. But yeah, most of these questions I am doing on my videos are the slightly challenging ones, so just bear that in mind. And it's not just one method that you can learn. There are several methods. The way your teachers might teach you a different method. If it works, then don't rock the boat, carry on doing that. However, if you're struggling with them, it's an alternative method for you guys, if you like. Okay, so now I've factorized this, which is same as that, and now I'm going to say m is equal to 8. In this case, m here can equal minus 9. Okay, now that's what m equals. I need to solve for x, so straight away I need to put that back in here. So if I put 2 to the power x is the same as 8. Now 8 in terms of 2 I can put that is the same as 2 cubed. So 8 is the same as 2 cubed, so base is now the same, so the powers are the same. In this case, x will equal 3. Okay, in this case, x will equal 3. And let's have a look at here. 2 to the power x equals minus 9. Now, you won't get anything here to the power here. Since this is positive, we're not going to get this out to be negative, so not possible. Okay. So there's only one point where those two are going to intersect, is when x equals 0, equals 3. Now we just need to find the coordinates, so what will y equal? So therefore, if I sub this into y equals 2 to the 3, y will equal, in this case, 8. So I'm getting this point from here. Okay, which will also work for this one too, 4 to the power 3, and then we'll get y. So this is going to be 8. So the point of intersection where we solve it is going to be 3, 8, which will work for both of them. Okay, so 8 will equal 2 to the power 3. And if I got 2 to the power 3, there's 64 plus 8 is 72. So that will also work. Okay, so this is the only point of intersection of those two curves. Okay, let's look at some more. Okay, now the sum of two numbers is x, and the product, which is multiplying, is 9.75. Show that this information can be written as a quadratic equation. And what are the two numbers? So first of all, let's just call them x and y. So the sum x plus y is going to equal, sum is 8, and the product xy is going to equal 9.75. Or you can put it as a fraction, 9 3/4. And we can put this top heavy, so that's going to be 9 times 4, 9, 18, 21, 36. 36 plus 3 is 39 out of 4. So I've got xy equals that, and yeah, and I can say, well, therefore y is equal to 39, and I'm going to divide it by x. It's going to give me 4x. Okay, so I divided that by 4. So now, what does that enable me to do? That enables me to sub this value for this here. For y can be exchanged for 39 over 4x. So that's what I'm going to do. I'm going to put x plus, instead of y, it's going to be 39 over 4x. And that's going to equal 8. Now I'm going to times everything by 4x. So multiply everything by 4x. Just because I want to get rid of the denominator, get rid of the fraction. Okay, so x times 4x is 4x squared. 4x divided by 4x, there will be 1, so that will cancel, so that will just give me plus 39. And 4x times 8, 8, 16, 24, 32x. If I bring that to the other side, I'll end up with 4x squared minus 32x plus 39 is going to equal to 0. So bringing that to this side. Okay, now what we need to do now is to factorize this. Now, first of all, we've done part A. This is part A done. Show that this information can be written as a quadratic equation. We've just done that. Okay, job done. Now, what are the two numbers? Now, what you could do is you could just plug this into your calculator, which will solve the quadratic. I'm going to try and factorize it, and the way I'm going to try and factorize it, I'm thinking of 3 times 13 is going to give me 39. And if I do 4 times one of them and add the 3, so if I do 4 times 3 is 12, that's not going to do it. I might have to just use it in the calculator. It'd probably be easier to just plug them into the calculator. I'm just going to double check. Oh, what I could do is split this up in 2 and 2. If I times that by 2 is 6, times by 2 is 26, and that's going to give me 32. Yeah, that's the way it's going to happen. Okay, so what I've done is obviously should be now practicing quadratics and should be able to do that pretty fast. So what I've done is I've split that up into 2x in each bracket here. So I'm factorizing this, and I need to double each of those 3 and 13. 3 and 13. They're both going to be the same sign, so that's going to be positive. So these are both going to be negative. Now let's just mentally do this in our head and see if it works out. 2x times 2x is 4x squared. 2x times minus 13 is minus 26. 3 times 6 is 3 times 2 is 6, minus 6. So you got minus 6 and minus 26, which is going to give me minus 32. And minus 3 times minus 13 is going to give me positive 39. Okay, so that works. So what I end up with is 2x can equal 3, where x will equal 3 over 2. The other number is 2x equals 13. So x will equal 13 over 2. Okay, so that's going to give me 1.5, and this one's giving me 6.5. And they will satisfy the above. It doesn't say the integers, so just be careful. We can have fractions here. Okay, it says nothing about the numbers, so happy days. Okay. Okay, now we're going to solve this equation. So this you should have to recognize as equation of a circle. Okay, and we're going to somehow plug one into the other to solve it. So I'm just going to take a second and think about how we're going to do this. And then we can try to, right, so I think the best way to do this is sub this equation into there. Now before we do that, let's just go to this equation and make y the subject. Yeah, let's make y the subject. So I've got x, y plus x is equal to 0. So I've got if I take that to the side, this is going to be minus. No, that's not going to be great. Let's just factorize this at the moment. Let's just say that it's the same as x factorize y plus 1 equals 0. Okay. Okay. What I could do is I could then go on to squaring both sides. So I could get x squared y plus 1 squared equal to 0. So I've squared all that. And I know that x squared, if I take that to the side, is equal to 4 minus y squared. Yeah, we could do that. I could replace this for this, so I could get 4 minus y squared multiplied by y plus 1 squared. Okay, so I've just literally squared both sides to try and get something out from here. Okay, so let's just have a go at this. I think there might be a few different solutions here, so let's have a look. We get quite a few solutions here. So I can factorize this, and I can say that, oh, that is difference between two squares. So I've got 2 plus y and 2 minus y. So that's difference between two squares. This is a double root, so I've got y plus 1 times y plus 1. So the y values I can have, I can get y can equal minus 2, and here y can equal 2, and this is a double root, so y will equal minus 1. Okay, so we've got those values for what y is at the moment. Okay, just double checking in, make sure that I haven't done anything. So square that. Okay, now let's go and sub these into one of those to find out what x can be. Okay, so if let's just use this one. Let's use these values, see how they go through. So first of all, if I say y equals minus 2, then x squared can equal 4 minus 2 squared. So that can equal 4 minus, now if I square that, that will give me positive 4. So it's going to be minus 4. So x squared can equal 4 to equal 4, which is going to equal 0. And square root of 0 is just 0. So x can equal 0. Just got to get 1. So we got a root here where we got x equals 0 and y equals minus 2. Okay. Likewise, I'll get the same if I put y equals 2. I'll get the same scenario. If I say y equals 2, then x squared is going to give me 4 minus 2 squared, and that's going to also give me 0, and therefore x will give me 0. In which case I've also got this other root, other intersection point, which is x is equal to 0 and y is equal to 2. I've got those 2 points at the moment. Now that's done. That's done. Now if y equals minus 1 here, okay, so I can put those in here. So I'm going to do this separate side here. So now sub y equals minus 1 into this equation. Let's put a box around this equation. Okay. So we get x squared equals 4 minus 1 all squared. So that will give me minus 1 squared is 1. 4 take away 1 is going to give me 3. And if I want x, I get square root of 3. And don't forget, I get plus or minus when I square root 3. Okay, so I get plus or minus for square 3. So therefore, I'm going to get 2 roots here. So I could get positive root 3 when y is minus 1. And I could also get a negative root 3 when y is minus 1. So all in all, find all my solutions, the answers, I can have root 3 minus 1. They could intersect at minus root 3 minus 1. Intersect at 0 minus 2. they could also intersect at 0, 2. So you've got quite a few routes, quite a few solutions here where they will cross quite a few intersection points. 1, 2, 3, 4 intersections. Okay. 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 Equation this where y equals k have one solution for all values of k is less than m. Find the largest value of m. Okay, so we've got this equation, we've got a cubic equation, and y equals straight line. So when y equals straight line, we just plug it on. So the largest value m. So one solution. Okay, the best way to do this is basically plot the graph here. It is a positive cubic, so it's going to be going upwards, positive, reach for the sky, okay, being positive. And the roots are going to be, you're going to have a root at x equals 2. And you're going to have 2 roots at x equals 3. So one root there and 2 roots at 3. Okay, and when x is 0, that's going to be minus 2. And that's going to be minus 3 squared. It's going to be times by 9. 3 squared is 9. So that's going to go through, let's just call this bit minus 80. It's going to cross there. So if I was to plot this graph, go at this, plot this graph, it's going to go through there, turn around, come back down, and dip back up. So the graph's going to be roughly like going through here, going through this point, it's going to turn, come down, then bounce on here, and then shoot back up. Okay, so that's how the graph is going to look. The cubic graph is going to come up, turn, hit 3, bounce off because there's a double root here, and then shoot back off. Now, let's use it different. Let's use right, okay. Now it says here, it has, so first of all, y equals k. So y equals k is any line going through here. Okay, so if I put a line going through here where it has one solution, all this line up to here, where it crosses that only once, it only has one solution. So all this will, obviously this graph, the cubic graph, continues to shoot off. So anything above here, it's going to have one solution. When I hit somewhere here, if I hit a straight line going along here, I'm going to get 2 roots, 2 solutions, one here and one here. Okay, anything between this point and this point, the axis, I'm going to end up getting 3 solutions because I'm going to hit it once here, another time here, and the third time here. Okay, so I'm going to get 3 solutions there. And then after this point, when it goes here, okay, when it goes here, I'm going to get, on this point, I'm going to get it 1, I'm going to get 2 solutions here, 1 exit. And then below that point, anything below the x-axis, I'm going to again end up getting back to 1 solution. Now it goes here, so the equation, this and this have one solution for all, values of k when k is less than m. Have one solution for all k less than m. Find the largest value of m. So we want a value of k. This is, don't forget, this is going to be the different k's we got. All these are y equals k. k1, y equals k2, y equals k3, etc. So all these are different. So we want all the values. We want the largest value of m for which underneath that, okay, when k is less than value, we have exactly one solution. But we can't use this. We can't. This has one solution. However, if I set this at, I don't know, 10 or something, anything less than 10, I couldn't say that, because as I'm going down that, I'll end up with these solutions. So really, if I look at the axis here, if it equals this, it will have two solutions. So when this is y equals 0, if it equals 0, there are two solutions, but anything less than 0, it will always give me one solution. So the largest value of m has to equal 0. So the largest value of m can be equal to 0, in which case when k is less than 0, there will only be one solution for all, okay, for all k less than m. All these lines less than when y equals to 0, you will always have one solution. Whereas we couldn't say that. If it was the other way around, greater than, then we could try to find where this point was, where the maximum point is going to occur, and anything above that would have one solution. But because it's less than, it's going to be less than 0. Okay.